For the 1.2 big ideas, we're going to be displaying quantitative data. So quantitative with numbers like height, as we described last time. A dot plot is going to look something like this. Make sure you put a label of whatever you're talking about on the bottom, and then you will just put dots at whatever numbers you got. So something like that. A stem plot is another way to organize data. So on any stem plot on the left is your stem, 0, 1, 2, 3, 4, all the way up. You can never skip in between, and I'll talk about that in a second. And then your leaves go on the other side. So if I just had that written, it would be 3, 4, and 5. Now on the next line, those numbers represented would be 11, 12, and 14. So you're taking the stem and adding it to the leaf. So 11, 12, 14. Now say I finish it out, there's a 37 and a 42 in there. So this is what I was talking about before. You still need to include the 2, even if there isn't any numbers in the 20s in your data. So you can never skip steps. And then a histogram will look something like this. Frequency is going to be the y-axis, and then some sort of label on the x-axis. So frequency is like counts. You can do it with counts or percentages. It's your choice. You'll see in the book they do it either way. So now in a histogram, a few important things. It's kind of like a bar graph. So you just go up. Let's say that's 5. There was 5 that fell in between 0 and 7. You just make a bar. But now, here is a key point for this. If there is a 7, it goes to the right. So the number here always falls on the right. So any number from 7 up to 13 would fall in that one. 14 would fall into the next one. So any number from 14 up to 21 would go in that one. So that's a histogram. When we describe a distribution, we need to describe 4 things about it. Those 4 things are shape, outliers, center, and spread. So if you can see, shape, outlier, center, spread forms the word socks. So the way to remember what you need to describe about a distribution is just to remember your socks. So as we go through these, when you're describing shape, you're describing, is it symmetric? or skewed. So something symmetric is going to look like that. If you would fold it over, it would match up. Now skewed, you have two options. It can either be skewed left or skewed right. Now the way to remember that is if you were skiing down a mountain, which way would you ski down? So I'll just draw a little nice guy here skiing. Skiing down, you would ski right down the mountain, so that is skewed data to the right, where this way you would ski down that direction, so that is skewing to the left. In other words, there's a little bit of data out here pulling things to the right, and there's a little bit of data over here on the left pulling things like the mean to the left. Outliers are just things that are way out of the usual pattern of the rest of the data. So just say anything about that when you're describing a distribution. Center, we're either going to use mean or median. Mean we're going to use with symmetric data. And median we use with skewed data. And we'll talk more about that. And then the S is for spread. There's lots of things that we're going to talk about with spread, how far apart the data is. So there's things like range. There's things like standard deviation, which we'll talk about. But for now, just say something about how spread out the data is.